All right, some new faces today. Super. All right, my name is Luke Miller. For those of you that don't know, I do apologetics, Christian apologetics. Basically, my calling is to defend or basically demonstrate and prove to people, okay, why is Christianity not a crock of nonsense? Okay, why does it matter? Okay, and the earlier sessions we talked about why apologetics, why Christianity was true, and now we're covering why evolution is completely false, right? First session we went through a lot of the problems with evolution in our schools, them teaching facts that they know, them teaching things that they know are lies, okay? And also, the next session we talked about, okay, survival of the fittest, why when you take nature and say, okay, when we look at animals and how they would develop given survival of the fittest, then what should we ultimately see? And what we see is something completely contrary to what evolution teaches. So we'll get into that just a little bit more, but for today, we're going to be talking about reproduction. Okay, more specifically, survival of the fittest, a portion of it. Okay, so recapping from last week, evolution equation. This is what evolution is, okay? It is survival of the fittest plus changes plus time. So animals change, and those changes get filtered by survival of the fittest. Basically, whatever is the most fit survives. And then over time, those changes add up to all the species that we have today. Now, survival of the fittest has three components. The first is getting food. Okay, if you have a change and that change makes it so you can't get food, what happens to you? You're dead. Okay, very simple. Second, if you lose something or you change that make you not as good as running away, or not camouflaged, or you can't fly anymore, and you become food, you cannot pass on your changes. Therefore, you are weaker, survival of the weakest, no, survival of the fittest, okay? The third is reproducing. Okay, so we talked about the first two last week. We basically said, okay, all these animals that have these changes that make them weaker, okay? That wouldn't work under survival of the fittest, because if the animal dies, it doesn't matter, okay? Now, the biggest problem for evolution is passing on those changes. Suppose that you have the best change known to man. Pretend that you could grow 2 extra limbs so you could hold your phone and type on a keyboard while you're sipping coffee and reading a book, okay? You have 4 arms, okay? You would be way more advantageous, or you'd have way more fitness, right, in scientific terms, than any other person, okay? If your arms worked, that is, all right? So, you win survival of the fittest, right? You survive. Okay, but what if you can't pass on the 4-armedness? What if you can't pass on that change? Game over. It doesn't matter what you develop or what changes in you if you cannot pass it on, right? If you cannot pass it on, game over, evolution cannot happen. Okay, so reproduction. Evolution must demonstrate how every change is made and passed on. Both need to be true, okay? They've done a lot of work on how changes happen, with the giraffe stretching its neck up into trees and somehow getting longer because of that, right? Or the lizards turning into birds, somehow growing feathers, which makes no sense for a cold-blooded animal, right? But passed on. I would argue that this session will teach you bigger problems for evolution than last session. Okay, why is that? Well, obviously, as I've already said, survival of the fittest needs animals to survive and pass on its changes. That's what it requires. And if an animal cannot reproduce or pass on its changes, then evolution couldn't have happened. Okay, I got a little bit ahead of myself, but that's the basic premise. Does that make sense so far? Cool. Alrighty, there's 2 kinds of reproduction, main kinds. Okay, there's a bunch of weird things with fungus. Okay, they are very weird, and there's a bunch of weirdness. I'm not going to get into that. All you need to know is that there are 2 kinds of main types of reproduction. First is asexual, and this is no male and female. If you've ever seen bacteria, they kind of just like, boop, split apart. Just kind of feel like it one day, and then there's 2 of them now instead of 1, right? And then there's sexual, which requires male and female. Okay, I'm not going to get into how that works already, but all you need to know is that sexual reproduction mixes DNA from both parents with chromosomes. Okay, so what happens is the chromosomes line up in the cell, they split apart, half of the DNA, or half of the chromosomes get shipped off from each parent to create a new life. Okay, that's how sexual reproduction works. Now, we're going to get into one example of survival of the fittest before we move on today to kind of walk through the process again, if you guys have remembered. Alrighty, so evolutionary history, evolutionary science, has stated that basically the first life was a self-replicating cell. Some kind of self-replicating RNA, DNA, cell, etc. Whatever it may be. Basically, it was something that somehow gained the ability, there's a lot of somehow in some things, right, because it's not clear. If you ever get into the origin of life, it's crazy. But basically, you started with something like this, okay? Maybe not like that, but something similar to it. Why? Because what's easier, right? To split apart, to copy yourself, or to have male, female, donate half your DNA to get a new life? What's easier? The splitting apart, right? You don't require anything else. You have everything you need already in you to reproduce, to make more of you, right? That's easier, simpler. That's why evolution says it came first. Now, the transition from asexual to sexual is what we're going to talk about right now. So obviously, if there are male and female today, which there are, look around, okay? Not complicated, okay? Well, yeah, never mind. Today it's really confusing, okay? Super confusing topic. Okay, but somehow, somewhere, someplace, there had to be a transition from something that was asexual to something that is sexual, right? There had to be the first male and first female, right? There had to be. Otherwise, we would just be splitting apart randomly, right? That doesn't happen. So obviously at some point, there had to be a first male and first female. That makes sense. Perfect. Okay, so for evolution to be true, it has to be the case that this transition happened. If this transition is impossible, evolution's false. Because obviously you never could get male and female, right? Now, question to you. If I have everything inside of me, okay, and I can just split apart, and now there's 2 of me, and then I can split apart, there's 4. What advantage is there for me to develop a male and female components of myself? There really isn't an advantage. What the evolutionists will say is, oh, you see, male and female, the reason why that's better for the bacteria is because, right, they don't have as many mutations, right? What? Okay. Kind of get a little weird here. What happens if siblings marry each other and have children? Okay, bad things happen. Okay, that's why there's laws against this stuff. Why? Because genetic mutations, problems in your DNA, when 2 people have the same one, and it multiplies the chances of them having a deformity or something wrong with them. Okay, so what they say is, male and female, that decreased the chance for mutations and genetic deterioration or destruction, your DNA getting destroyed, to happen. That's why. Now, the first thing I would say is, okay, how'd the bacteria know that, right? First of all. Second of all, okay, is that truly an advantage? Okay, let's think about last session, step by step, okay? So pretend you have one bacteria. Oh, actually, let's actually get into a story. Okay, so we have 2 bacteria here. And they are trying to evolve to become male and female. Doesn't matter which one. Let's say the yellow one's male, the purple one's female. Okay, there we go. Alrighty, so let's pretend for a moment that one bacteria, right? Just imagine one bacteria surviving right now. Okay, one bacteria says to itself, okay, I need to become male and female because if I don't, I'm going to eventually have the genetic destruction because of all this scientific mumbo jumbo. Very smart bacteria, by the way. Second, okay, so pretend it takes 100,000 years that it evolves. Oh wait, bacteria only live for a couple hours. Well, it kept on telling its children over 100,000 generations, you need to become female, 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 you need to become female. Eventually it becomes female. Great. Where's the male? Okay, let's pretend that we have the same case. But this time they're telling all their grandchildren over 100,000 years that they need to become male. Same problem. Oh, but this time there's going to be 2 bacteria who get together and they say, okay, that didn't work for the last 200,000 years, so we have to develop both male and female, so I will spend the 100,000 years developing male, and you will spend the next 100,000 years developing female, right? Well, see, the funny thing about bacteria is they're not very smart. So most likely, if they were to do this, they would have both female, right? Both males, right? And what does that mean? No reproduction. Okay, is there any advantage yet? Over 100,000 years of development. Any advantage? No. Why? There's no benefit gained, right? Just what we talked about last week, okay? Pretend a dinosaur gets feathers. It's cold-blooded, gets feathers, okay? Cold-blooded creature, insulated. What benefit is that? None, okay? Yeah, I want to heat up a pan of water. I want to boil a pot of water, so I'm going to put them in a DoorDash insulating bag and then put them on the stove. Smart. No, there's no advantage, okay? Now, oh, spoilers. Okay, pretend they both became male and female, okay? Oh, but they were too far apart. Bacteria, they're super microscopic, so let's pretend they're a foot apart. Oops. Or maybe the male developed 50 generations before the female. Oops. Or the female 100 generations before the male. Oops. Impossible odds and no advantage. Survival of the fittest says what? Should we ever have sexual reproduction? Should there ever be male and female? No, there should be a bunch of super bacteria running around. Okay, that's what should happen. Because there's no advantage, step-by-step process, remember evolution, tiny steps, right? There is no advantage for the bacteria. Now, here are the miracles the bacteria needs to overcome. Okay, just a recap. Well, so when that bacteria is evolving, right, over 100,000 years, how did it reproduce? Did it still split apart? What about when it's half and half? What if it's like half asexual or half sexual? How did it reproduce?
Just lived amazingly long.
Yeah, maybe it lived a very long time. No, because it couldn't finish. Remember, evolution's not miraculous. It doesn't make big jumps at once. That's not scientific. If you believe that evolution can make these big jumps, you're unscientific. You don't believe in the science. Okay, mutations, very small changes. How did it reproduce when it was half and half? Or quarter and 3/4?
Neither one would work.
Neither one would work. But what if? What if you had splitting apart and you didn't affect that at all, but then you started on something else? Okay? Pretend you spend the next 100,000 years splitting apart, but you're also developing male and female. Would you ever have male and female if you could just split apart? No. You see why that makes sense? Or rather doesn't make sense? There's no advantage. Okay, now, beyond that miracle, they need to mutate male reproduction. Beyond that, they need to mutate female reproduction. At the same time, same place, two different bacteria, because it can't be the same one. Otherwise, it would reproduce with itself, and that'd be weird. Okay? Both need to know how parts combine. They've never done the tango before. They've never done the bacteria tango. Okay? They just know how to split apart. They don't know what to do. Okay? It's not like they have instructions that come along with their new changes. That's not how the animal kingdom works. Okay? In the lab, if we put legs growing out of flies' heads, does it work? Do they know how to use them? No. They're like, I'm weird now. They don't know. Okay? Same time, same place, right? 5 miracles that need to happen for this one transition to occur. Plus, it fails survival of the fittest because there's no advantage. So on top of this, they still are not survival of the fittest. We should never, evolution can't happen because we'd never ever get there, according to their own equation. Okay, now, moving on to sexual reproduction. Okay, pretend somehow we got male and female, pretend, okay? Now, to reproduce with this method, the animals need to be similar, right? You can't have you can't have like a monkey and a shark, okay, that won't work. I mean, be a weird hybrid. It won't work, okay? Why? Because they're not similar enough, okay? They need to have the same number of chromosomes. Okay, we'll get into that later, okay? And their offspring need to be fertile. Pretend for a moment that you have 4 arms, we get back to our first example, and you reproduce with another person, and you have a baby with 4 arms. Great, you passed on your change. What if that baby can't have babies? Oops. So somehow evolution say, wow, there's all these exceptions of these 2 animals reproducing and having a child, right, that has this change. Wow. They forget to tell you that the next step can't happen. That, hey, if by some miracle you can get a offspring that carries on this weird genetic change, the offspring will not have kids. We'll get into that later. Okay? Point is, just because they show an exception with one step doesn't matter. You need to have every single step through all of evolutionary history or else it doesn't work. Okay, with me so far? Perfect, we can move on. Okay, What chromosomes are, okay, chromosomes themselves are not super special, okay? They're not super wondrous things. What chromosomes are is they're the way that your information, DNA, is stored in your cells, right? It's the way they're stored. Think about like books and chapters. Okay, that's what chromosomes are. They are not information. I can give you a book. That's not information. Okay, the words, letters, and everything, that's information. Okay, chromosomes are the way it organizes it. Does that make sense? Perfect. So, an example. So you have all the Legos, right? And the Legos are like, that's all the DNA inside, okay? But then when you make something out of that DNA, or you have all that information that forms a coherent pattern, right? That's what is inside the chromosome. Okay, each individual gene doesn't matter. Chromosome is just a way that it's packaged. So think about like an Amazon package. That is what a chromosome is, right? Now, pretend for a moment that we swap all your chromosomes, add a bunch, and jumble up all the way that your information is structured. Okay? Now, human DNA, human chromosomes. Okay? When I look in your first chromosome will have the same type of information that my first chromosome has. Your fourth chromosome will have the same information that my fourth chromosome has, et cetera, through all of them, right? Okay, what if we jumble the order? Okay, what if I added 5 chromosomes to my DNA, somehow, miraculously, and I had a whole bunch of jumbling up with what is actually inside all of my chromosomes? Because remember, when you say more chromosomes, that doesn't mean that you have more information. Okay, a monkey has more chromosomes than a human. Okay, does that mean a monkey is more complex or has more information? No, it's the way it's structured and ordered. A potato has more chromosomes than a human. I think we all can agree that a potato is not more advanced and complex than a human. Okay, it's the way their books were smaller, right? Their chapters are smaller. For the potato, they have a bunch of chapters, but their chapters are smaller. Right? There are some animals with 200-some chromosomes, right? Point is, chromosomes adjust the way it's ordered. Now, the problem with chromosomes is that if you do jumble up the information, if you do jumble up that your first chromosome may your hair color, for example, and my first chromosome may have my legs, okay? If you try to have kids with different structures, what's going to happen? Nothing, because the cells are going to be like, hey, cells, you have all these Legos. Now build a cabinet. The cells are like, I don't know what to do with this. It's not right. Something's wrong. Okay, that's why a monkey can't have offspring with a shark, because their DNA and information is structured in different ways. So the cells in your body are like, I don't know what to do with this. I can't. I don't have the tools. I don't know where everything's at. I have no idea what's going on. That's why chromosome order and chromosome count is important. Okay, that's your very basic crash course on genetics. Okay, moving on. Now, if the directions and organizations don't match up, the offspring has serious problems. In all likelihood, death, or it'll never even start. Okay? If you have a female part that's a shark and a male part that's a monkey, they won't even do anything. They'll kind of like sputter out before anything happens. Why? Because it's just not even compatible. It just doesn't work. That's just how things are. That's science. I don't know the scientific mumbo-jumbo to actually demonstrate to you genetically why that's the case, but I know this is the case. Now, does anybody know of the great controversy of the mad cowboy? Okay, so once upon a time, there was a farmer, and this farmer had a ranch of donkeys and horses. Okay? And this farmer saw a wandering cowboy with his horse nearly dead and said, hey, Mr. Cowboy, I've got a great deal for you only today. I will sell you a brand new spanking donkey for a quarter of the price it usually would, because your horse is kaput, it's gonna die. It has some problem, whatever the problem might be. So the cowboy said, quarter price, perfect. So he buys, right, this animal from the farmer, and then he rides off back to his ranch. And he's like, man, I have this spanking new donkey. I'm gonna breed this donkey with my other donkeys. Problem was, the cowboy got gypped. Now, why did he get gypped? Okay, this is actually historical. The story's not true, but a situation like this is true. The farmer sold him a mule. Now, who knows anything about mules? What's the problem with mules? Can't reproduce. Mules are sterile. They can't have kids. They can. There are exceptions to the rule, but then their kids can't have kids, or there's a bunch of weird problems. It's the exception that evolution will try to sell you. Okay? I have been on these sites. That's the exception they give. Well, actually, there was one case where this happened. Oh, great. One case where this happened. What did their offspring do? Oh, their offspring couldn't have kids. Right?
How's it even used?
What's that?
I'm confused. How's it even used?
A donkey and a horse have a baby,
That's all
and then it can't, because it's like a mutant.
So,
A tiger and a lion can have a liger, but the liger can't have babies.
yep, I'm sorry. I'll just get into that. That is this next slide.
I love ligers because of Napoleon Dynamite. He's drawing a liger.
Incredible. You'll see him in a little.
Okay, to clear up, so I got a little bit ahead of myself. Okay, so this guy is a mule. Okay, a mule has 63 chromosomes, and that is why it's sterile. Okay, because it's screwed up. Okay, now why is it screwed up? Okay, that's the nice way of saying it. All right, why is it screwed up? Because a donkey has 62 chromosomes and a horse has 64. They have different numbers, and look at what happened to the mule. What number? Smack dab right in between. So obviously when they reproduced, something didn't happen right. Why? Because do you ever have a human, right, who reproduces and has a child with like 100 chromosomes? No. You don't change chromosome numbers because that is the structure that keeps everything from going haywire, right? It's nature's way of correcting itself. Hey, there's a problem, a mule. Well, this abomination of nature, good thing it can't reproduce. In reality, it's not an abomination of nature. The only thing bad about a mule is it can't reproduce. Okay. But the important thing is, what? What's the important thing? The important thing is 64, 62, 63 can't have kids. Now, what's the point I'm making? Point I'm making is, okay, so remember all the way back to the beginning, evolution had to create every change and pass it on somehow. That's evolution's burden. How do we get all the different chromosome counts? How do we get them? Well, they had to have made other chromosomes at some point, right? There had to be a first 64, a first 62, a first 48, a first 46, right? There had to be a first because there wouldn't be us. There wouldn't be those numbers if there wasn't a first. Here's the problem. Pretend that horses came from donkeys. Well, that doesn't make much sense. Pretend donkeys came from horses, okay? Horse is majestic, donkey kind of, okay. Pretend the donkey came from a horse. Okay, pretend for a moment. Two horses gave birth to a donkey through some weird genetic incident. It had some severe problems and something out popped the donkey, right? Who's the donkey going to reproduce with? The donkey's brand spanking new. There's only horses so far. Who is the donkey going to reproduce with? A horse. Wow, oops. What happens? Dead. Donkeys go extinct. Because they have no other donkeys to reproduce with. Poor donkeys. Point is, 64, 62, sterile. How did we get the 64? How did we get the 62? How did we get the 48? How did we get the 46? How did we get the 16? How did we get the 56? How do you get all those if you try to reproduce and it fails? You with me so far? You see why that's a huge problem. How do they get the chromosome counts? Where do all these numbers come from? Okay, a lot of mammals come from other mammals, evolution says. They had like the small, weird, kind of androgynous mammal, and then it kind of separated into like monkeys or horses or humans, right? All these different kinds of things, right? They didn't come from bacteria, okay? Mammals came from other mammals. Mammals can't do that. Where'd that count come from? Interesting. So, here's a demonstration of how it works out. Pretend I didn't want to put 64 X's and 62 X's. Okay, I was lazy. Okay. Point is, 2 less. Okay, and what happens? We'll go back to that number, 63. It means that somehow like half of these two created a new one, right? Those two are the important bits. They don't have the same number, so there's problems. They don't match up, they can't have babies. That's your genetic lesson of the day, or your second. Okay, second genetic lesson of the day. If the X's don't line up, if they don't have the same number, they can't have babies. And if they miraculously can, their babies can't have babies. So on and so forth. Problem is, there's always problems that arise the further you go down the line. Okay, now here's, if you're interested, here's the chromosomes of the donkey and horse. Or no, wait, I believe this is donkey. Okay? Now, here's the funny thing about chromosomes. A donkey doesn't really have 62 chromosomes with different stuff. Here's how chromosomes work. Donkey has 31, right, chromosomes that have information, and they have a duplicate. Genetic pairs, chromosome pairs, are actually a copy, are copies. So when they say 62 chromosomes, in reality only 31 of them have the information, and there are 31 copies of that information. So you can take the 31 and reproduce with another donkey that has the 31 copies, and they both share their copies with one another, and out pops a new baby. Okay, that's genetic lesson. Point is, you have to have the same number. Okay, moving on. My favorite example, this guy. Okay, someone said it earlier. What's that guy? A liger. That's a tiger. King of the jungle. That's a liger. Tie-ins. Yeah. So, fun fact, a liger, I think, yeah, they call them different things because it depends. It's weird because it depends if the lion is male or the tiger is male. It's different because of that. I don't know which is which. I don't know. Point is, that's a liger. Liger could eat Mr. Tiger for breakfast. Okay, it's twice as big, probably, just by looking at it, okay? So, a liger and a tyon, right? I don't have a picture of a tyon, this is a liger, has 38 chromosomes, okay? The liger has the same chromosome count. Wait a minute, why did I do that? Oh, that's next slide, sorry. Okay, now this liger, would he be more fit or less fit than the tiger? More. So if a tiger and a lion had a baby, and that baby was this massive, okay, who do you think would be the new species on the block, according to survival of the fittest? The liger. Why? Because he could beat up any other male tiger and be like, I'm the king of the block now. Deal with it. I could sit on you, right? Makes sense. He's more fit. He beat the other one up really easily. He beat the lion up easier because the lion's smaller than a tiger, right? True king of the jungle, okay? Ligers can get up to 800 to 900 pounds.
How about a lion?
Lion's close to 300-400.
So it's actually bigger than a lion?
Way bigger. Almost twice. More than that sometimes, depending if it's a female lion, male lion, or different types.
Wow.
Huge cat, all right? Now, tigers and lions, okay? Tigers and lions both have 38 chromosomes too. Okay, so a liger, okay, this is a tongue twister. Tigers and lions both have the same chromosome counts. They're both cats. Cats, Felidae, right? Maybe I'm butchering the pronunciation. Basically, they're the same type of animal. Okay, they have the same chromosome counts. They have an offspring with 38 chromosomes called the liger or the tyon. Does anyone know the problem with ligers and tyons? Just guess. Wild guess.
They can't make.
They can't reproduce. Oopsie daisy.
Why though, if they have the same amount of chromosomes?
That's not a question for me. All I know is they can't. I trust the science on this one, buddy. Trust me, I'm not a geneticist. Point is, they have the same chromosome counts. They're similar enough to reproduce with each other, but the babies are sterile. So in case you weren't convinced that evolution has humongous serious problems about chromosomes with horses and donkeys, which had different chromosome counts, even animals with the same counts still can't have offspring that are fertile. So tell me, survival of the fittest says what for the liger?
Dominates.
It dominates. Survival of the fittest says, liger, go for it. You are the biggest, strongest. There's no you could kill a water buffalo by yourself. Who needs hunting in packs when you can just literally weigh more than the prey that you're hunting, right? What's the point? Can it pass on the change? No. So can evolution happen if it cannot pass on the change? No. If 38 and 38 can't make another 38 that's fertile, how could you make the 38 in the first place? How could you make the 36 in the first place? Does that make sense? Well, evolutionary science, it doesn't make sense, okay? Because how did on earth you even get there? Everything we know about science and genetics tells us that there's big problems, even when you have the same count, the same family. Not similar enough. But how the heck did you get the chromosome count then? Where'd it come from? Where'd the number come from? Scientific miracle, right? No. Reality didn't happen. There's no mechanism by which this does happen. Okay? Now, here's an evolutionary tree. Maybe you can't see this. This is really small. I tried to make it as big as I could. Okay, sponges are down here. There's like sea anemones, and there's like flatworms, shellfish, shells, that kind of stuff. Worms, like snails, mollusks. Tardigrade, those like weird water bear things. Worms, and then we go into arthropods, and then we split off another different way, and we go into like echinoderms, and then like vertebrates, where we have man, bear, stingrays, all that kind of stuff. Okay, this is very basic. This is from National Geographic. Okay, this is the evolutionary tree, the tree of life, as they say. Okay, now, question for you. If we were to say, okay, pretend the beginning organism was the most simple there could be, in what order do you think the chromosomes would go? You think, what would you expect to see in the chromosome counts?
A lower amount.
A lower amount to begin with, sure, right? So you just less to more. Does that make sense? Is that what we would expect to see? Right? I think that's fair. Less complex to more complex. That's what we'd expect to see, right? There's no order. Poultry and a dog have the same number.
Which is way more than humans.
Which is way more than humans, by the way. Apparently you're less, complex than a pig. Sorry. Right? Pig, or no, sorry, not pig. Poultry, chicken. Right? So saying someone you're chicken, it's a compliment. Right? Okay. Buffalo, 48. Cattle, 60. Goat, 60. Camel, 74. Right? Mouse, 40. Guinea pig has more than a human. I don't know. I have no idea. Cat, 38. There is no order. Okay, well, if you're not convinced, here's a different one. Okay, carrot has 18. Cat has 32. An adder's tongue fern has 1,262. Don't ask me why that's that number. I don't know. It's weird, though.
Now we say ferns were some of the first things.
Yeah, true. According to evolutionary history, ferns were some of the first things to develop. Maybe it went backwards. I don't know. Dog, more than a human, more than a chimpanzee. Potato, more than a human. I still find that funny. Okay, a garden pea has 20 and a fruit fly only has 8.
Potato head's a compliment, not an insult.
True. True. There is no order. There is no order. Take it and leave it. I mean, I would think a human would be the most advanced, but there's no rhyme or reason to the count, the order. There is none. What would you expect to see if evolution was true? You'd expect to see some kind of pattern, right? But see, here's the funny thing. We'll go back to here. Would you say that buffalo and cattle are closely related to each other, evolutionary speaking? Like they're pretty similar, right? 48-60. Guess not. Okay, sheep and goats. You'd say like, hey, they're pretty similar. Nope, a cow is more similar to a goat than a buffalo, according to chromosome counts. Because remember, to change your chromosome count from 60 to something else, you have to have a what? A genetic miracle. Somehow, you have to change your count with having fertile offspring. How did it get there?
Sheep and elephants.
Sheep and elephants. Where's elephant? Yeah, sheep and elephants. Elephant 56, sheep 54. They're related. No. In fact, there are things online. It literally said, see, this is a thing I found from an evolutionary presentation. Can different organisms have the same number of chromosomes? Yes. But can any conclusion about relatedness be made from this? No. So the evolutionists say, no. If something's related, it has nothing to do with their chromosome count. How else are we supposed to judge them? Because to reproduce with each other, you have to have the same count. That's a prerequisite. Otherwise, you fail. All right. So summarize this little point here. Animals cannot have fertile offspring when they have different chromosome counts. We know this from the donkey and horses. Okay? Even if they did have identical counts, it does not mean that they have fertility. Lion and tiger equals liger. Okay? And for evolution to be true, all chromosome counts must be created. So a question to you. If we can't have differences of 2, a donkey and a horse is a difference of 2, and we can't have a change with a difference of 0, what can we do? What's left to do? Well, I'd argue that the last thing we can do is, we'll talk about the 5 miracles first. Sorry, I'm getting ahead of myself. I'm excited for this slide after this. Okay, so 5 miracles of evolutionary reproduction, chromosomes, all that kind of good stuff. 1, there had to be a male and female at the same time, same place, obviously. But we're not talking about in general, we're talking about the new species. Okay? So the first goat, the first 56, or whichever the goat was, I forgot. Right? That had to be the first number. And that first number had to have another individual of the opposite sex it can reproduce with at the same number. That's the first miracle that needs to happen. Second miracle, the animals must give birth to different animals with different chromosome counts. Having an offspring with a different chromosome count, is that a common occurrence or a excruciatingly rare occurrence? Extremely rare, okay? You don't have a child with like 50 chromosomes. You don't.
I think it's really interesting on the first one where they talk about that everything was these micro change, little, right? But it's not small because you can't have 50.1 chromosomes. You can't have 50.01 chromosomes.
True.
You have either 50 or you have 52 or whatever, you know? So I think that's interesting. Why?
Oh, absolutely spot on. This, in and of itself, this is another argument you can use that, yeah, chromosome change violates evolution by its very principle. Why? Because evolution is small changes and chromosome jumps are entire 2 chromosomes being added. Or no, sorry. They say 2 chromosomes, but in reality, it's 1 chromosome, but the copy of it. So when they say 58 to 56, that's actually just 1 chromosome and a copy of that new chromosome, if that makes sense. So it needs to add in a whole stinking new chromosome in one go. There is no animals out there with like 0.5 chromosomes. Okay, there are smaller chromosomes, but they're complete. Okay, meaning they have all the information the animal needs to have there. Okay. Now, third miracle. The animal needs to have different chromosome counts than their parents, but still be fertile. Okay, that doesn't happen, and if it does happen, it's excruciatingly rare, and even if it does happen, about the super excruciatingly rare case, their children's children can't have kids. Or if their children's children can have kids, guess what they're having? The original species, not the new species. It's weird. It like corrects itself. Nature corrects itself. It's fascinating. Okay? Fourth miracle. The animals must give birth to the offspring that keeps the change instead of getting rid of it. Okay? So instead of the mule somehow being fertile and then having another mule, no, the liger and Tyon, okay, they can have children that are fertile, but guess what? What does that new children that's fertile have to reproduce with? A tiger or a lion. And guess what kids they have? Do they have another liger Tyon? Nope, they go right back to lions and tigers. Nature has this big circle thing. It's like liger, Tyon, ooh, that's wrong. So they go right back up to tigers and lions. Okay? Nature corrects itself. Miracle means that evolution has to have at least 1,262 changes because of the one fern, right? With all the 1,000 chromosomes. There has to be at least that many. Right? That doesn't happen. Fifth miracle. Evolution, we need to do this hundreds of thousands of times. Okay, look up. When you get home or on your phones, look up the different crazy chromosome counts. You'll be shocked. I think there's like a fly that has like 6,000 or something. Okay, point is, there's no consistency, and there are thousands of different counts from all animals on the entire planet. Okay, insects, right? Everything. Bacteria. Everything has different counts. They had to somehow get it. Every single one of those things has like a scientific impossibility or rarity. And evolutionary science says, oh, that's A-okay. We still did it somehow. We may not know the... Yeah. We know evolution must have happened because we have fossils. We don't care about the genetics of it, but we have fossils. Therefore, evolution happened. Good luck. Good luck. I put you in a lab, and I say, okay, make the different chromosome counts. Good luck. I'll bet a lot of money you can't do it.
Hey, why do they say that it's possible because of fossils? I'm uneducated in any of this.
No, it's fine. It's unfortunate. Yeah, I'm sorry. You had to kind of be here for an earlier session. Basically, they have like 5 or 6 things they like to point to in our textbooks, like the different Darwin's finches, if you heard of them. So basically, they say there's different species of birds, and birds can change depending on the weather. So they say, if birds can change that easily depending on the weather, then of course they can make big changes just given enough time. So they basically use the equation of animals change, being fit, survival of the fittest, meaning they don't die right away, and then over a long period of time, every animal can be made. That's their argument. And they say, we have fossils of these weird animals. Therefore, they had to get there somehow. And since God can't do any of it because we don't believe in that supernatural nonsense, because I'm an enlightened scientist person, right? I must believe in what? I must believe that this can happen. Because the alternative is God, and we can't have that as we're enlightened scientist peoples, right? No. So sorry, maybe that clears it up a little bit.
That's probably why you never made me interested or...
It's complicated. Don't get me wrong. It is excruciatingly complicated. Basically, all you need to know is that modern science on genetics says, yeah, good luck.
Have you ever looked into the humans that are born with different chromosomes? Okay.
Oh, that's a
Oh, bummer. Cats and dogs are first. Okay. That's coming up. That's the real fun stuff. Okay. So here's the example. Here we're gonna walk through this now. This is gonna make sense now, hopefully, if I did my job right. Okay. So this funky thing, I don't know the name of it, and I couldn't pronounce it if I knew the name of it. Okay. If I put it down on the bottom of the screen, it'd say some weird 5-syllable thing. I don't have no idea. Okay. This is an ancestor of cats and dogs. Look up online. You can look it up right now if you want to. The ancestor of cats and dogs, and you'll find an article with that picture because that's where I got it from. Okay. The cats and dogs had a ancestor. They both came from the same point.
Is that chupacabra?
Something. I don't know what it is.
I don't know. Kind of looks like a chupacabra.
Well, apparently this thing, since it's the ancestor of canines and felines, it was also the ancestor of the lemurs, the seals, the hyenas. This is like a weird amalgamation of all of them, right? Basically, an AI combined everything and made it. I don't know. Point is, a dog has 78 chromosomes and a cat has 38. Common ancestor. How many chromosomes does this thing have? No idea. Science has no answer. Why? Because we have no way to test it, because they are extinct. Okay, now, use some logic here. Okay, so we know that dogs and cats, no, I just have an arrow. The cat didn't turn into a dog. It was the weird thing that turned into cats and dogs. Okay, don't get me wrong here. I just say that for sake of easiness. Plus, I can have a picture of cats and dogs. Okay, so simple math, 78, oh, spoilers, 78 minus 38 is what? 40. So there's 40 chromosomes apart. Okay, that means whatever count the original weird cat dog thing had, it could be smack dab right in the middle, it could be on the dog end, it could be on the cat end. We don't know how many chromosomes it has, but we know there's a difference of 40 between them. Okay, now pretend that we could only change chromosomes one at a time. That'd be 40 changes, 40 scientific miracles. Or if we did 2 at a time, which is like donkeys and horses, although that is, we all know why that can't work, would be 20 miracles, right? 20 miracles to get cats and dogs. That's just cats and dogs. Remember, there's thousands of species, okay? Now, just cats and dogs would require at least 20 miracles. Okay, so when you're talking to someone who believes in evolution, You can ask them, okay, cats and dogs had an ancestor, right? They say, yes. And you say, okay, cool. So I got a question for you. I'm not quite sure how I phrase this, but here I go. So if you don't understand me, just let me know. So I looked into genetics. Donkeys and horses, right? When they have kids, they're called what? Mules, right? Cool. But what's the problem with mules, Mr. Evolutionist? Mules can't reproduce. Okay, so right, that's what I get too, right? Problem is, how did we ever get to cats and dogs, Mr. Evolutionist? Because don't species with different chromosome numbers reproducing end in failure? How did we get cats and dogs? Did the ancestor somehow magically jump 40 chromosomes to get to one side or the other? I don't see how evolution can solve this genetics problem. Can you please tell me, Mr. Evolutionist? See, here's the kicker. Can you please tell me how this is possible?
It had to happen because we know evolution's true.
But see, here's the problem.
We just don't know all the answers.
We don't know all the answers. Sure, we don't know all the answers, but are we saying that modern genetics is wrong? Or are we saying that Darwin was, okay, so we're saying Darwin is right, but modern genetics is wrong. Do I understand you correctly? Why should we trust Darwin, who was an 18th century person, right, than our 21st century scientist lab coat billions of dollars in research and equipment? Who should we trust? Because it seems to me like we'd trust the genetics people. Darwin had no idea what DNA was. Okay, if you phrase it that way, if you take the side of science and make it seem like evolution is not taking the side of science, you have an out. What's that out? I'm sorry, but I cannot believe in some 18th century person, right? Because what do they say about the Bible? I can't believe in some, ancient 2,000-year-old people, right, than scientists. I'd rather go with the scientist, the atheist says. So you can do the same thing. You can say, I don't want to believe in the 18th century sailor person that sailed around the world in a ship that looked at birds. I want to side with the billions of dollars in research for scientists nowadays. That's what I want to trust. And they said that this just doesn't happen.
Or you can reverse psychology. Like, see, now God does exist. Because look, the miracle.
True. You could do that. Whatever you want to say. I'm just giving you one option.
You can make fun of them.
Yeah, you can absolutely make fun of them.
Why are you believing in miracles?
Mm-hmm.
Yeah, you believe in miracles, but
See, what is the card they use against Christians? Oh, why don't you believe the science? You could do the same thing to them. Why don't you believe in the science? Why don't you believe in modern genetics? Please demonstrate how this is possible. Because all the information I know about says that this isn't. Why are you unscientific, Mr. Evolutionist? You believe in an old theory that's over 200 years old. I believe in modern research. The same logic they use to combat you as Christians believing in a dusty old book called the Bible is the same reasoning you can use to discredit Darwin. Okay? There's no difference in the reasoning. It's the same stuff, right? They're just but of course they won't submit to that, right? They won't, okay? Realistically, you might stump them, but they're not going to be like, oh, I've got to convert my life now. If it does happen, great, but don't expect that. Very prideful. They don't want to be put in their place by a Christian unintellectual, okay?
let's do a miracle on this fella right here.
Exactly. Sometimes that's what it takes.
What's really what's going on? Give us the
Absolutely.
That's right.
But it doesn't hurt to, mock them just a little bit. Just humble them, be like, oh, you know what? You've been ripping on Christians in chat rooms all this time. What if I throw a wrench in your belief for once, huh? What if I give you a little bit of spice to challenge your beliefs, right? Same thing. You just have to do it in love, though. Okay. So, how much time do I have left? I have no idea. I have not been paying attention.
Half an hour.
Half an hour? Sweet. I'm on time then. Okay. So, question. Why did Mr. Neanderthal, beautiful looking fellow, why did he go extinct?
He never existed yet.
Well, okay. Okay, smart Alex. Okay. So evolutionary history said that there was an intermediate form, or a in-between, or in the middle, between ape and man, called the Neanderthal, right? Now there's a lot of things online where they say that, yeah, humans killed them with warfare, or they died because of disease, because of the ice age, it thawed and all the new bacteria came out from the soil, etc., or starvation. There's a bunch of reasons why they give that the Neanderthal died out. Now, the interesting thing is, intermediate forms. Here, I'm going to try to lay down a little bit of a logic line here. Okay, in evolution, every transition has in-between points called intermediate forms. So between lizards and birds, there had to be a what? A lizard bird, right? Between, I don't know the name, I'm just calling it a lizard bird, okay? Point is, there had to be something in between, because you can't jump from lizard to bird, because that'd be a miracle, and miracles don't happen in evolution, okay? Because if they did, they wouldn't be evolutionists, would they? Nope. So there had to be something in between. So between ape and man, Neanderthal, ape man, okay? When you really look at evolution, it's not really that scientific. Okay, it's like lizard bird, lizard bird. Ape man, ape man. It's not super sophisticated. Okay? Fish, amphibian. It's a half and half. Look it up. Tiktaalik. It's a half and half. That's literally what they do, is they say, okay, we have two things. Boop. They know nothing about it. They have its bones, maybe. They know nothing about it, but it's a half and half. Okay. Question. How many halves and halves are there today? How many lizard birds are there? How many lizards with feathers exist on the planet today? Anyone know? 0. Okay. How many Neanderthals exist on the planet today?
I don't know, some people act like it.
True. True. 0. 0 exist. Why? Because they went extinct, they'll say. Question for you. Okay, if a species goes extinct, according to survival of the fittest, which survival of the fittest says whatever's fit survives and whatever's weaker dies, then all the intermediate forms were what? Weak. Okay, wait. So, if they're weaker than the end, so if the Neanderthal is weaker than the human, are they stronger than the ape? Are they better than the ape?
Yes.
Why are apes here? Why do apes exist? Yeah, apes are weaker than Neanderthals. Why do apes exist?
Because they can reproduce.
They can I guess so. They have to come up with some reason. But think about it. Neanderthals go extinct because they are weaker than humans. But apes, we don't talk about apes. Oh, apes exist because they're what, weaker than Neanderthals. So wait a minute. The reasoning that they say Neanderthals went extinct is because humans were better, or because of disease, starvation, whatever, right? Then why are apes here? Does that make sense? Yeah. Wouldn't apes go extinct when the Neanderthal came on the scene? Because if the Neanderthal's better, okay? Oopsie. Did I shut this off? I did. I shut off my clicker. Okay. Why doesn't the middle species exist? Because isn't the middle species better than the first species, the beginning species? Isn't the lizard bird better than the lizard? Well, doesn't it have to be if survival of the fittest is true? How'd you ever get to birds if you never had a lizard bird? Right? Because to get from lizards to birds, you would need to go from a lizard to a bird. That makes sense, right? If evolutionary history is true. So this lizard bird had to be what than the lizard? Better or worse? Better. Why the heck is it extinct? Does that make sense? Pick any other transition. Horses and donkeys. Any other thing works. Well, that doesn't really work because they're super similar. It's really hard to understand them. That's the chromosome problem. But lizard birds. Why are lizard birds extinct and lizards aren't? Why are Neanderthals extinct but apes aren't?
Guess the lizards are better than the lizard birds.
Yeah, the lizards must be better than lizard birds. And what does that say with survival of the fittest? If lizards are better than lizard birds, then were lizard birds worse or better than lizards? Worse. But wait, then how did it survive? How did it ever get to birdness if it was weaker than the lizards? Okay, that's kind of what we talked about last session, was evolution has to increase. Otherwise, if you have a new change, like feathers on a lizard, that's cold-blooded, it makes it weaker. And being weaker means you die. Or you don't get to reproduce because you're beat up by all the other males. Or you just are slow and you become food for a hawk. If you get weaker, you die. Survival of the fittest. Where'd all these species go? If they did survive, or if they didn't survive, if they were weak, how did they reproduce to pass on their changes long enough to get to the next step? That doesn't make any sense. Survival of the fittest is true. We know that to be certain. Evolutionary science says, well, it had to happen, right? But the reasoning makes no sense, because why do all the in-betweens die, but all the beginning and ends don't? That makes no sense. It's almost like the in-betweens are made up. Oh, wait. It doesn't follow any reasoning. If the in-betweens are extinct and the beginnings and ends are not extinct, then survival of the fittest says the beginning and end are more fit. The middle would be less fit because it's dead. It doesn't exist anymore. How did evolution happen? They say always it increases. It has to. That's what they say. Obviously not. Okay, that's another wrench you can throw in. Where are all the Neanderthals, or where are all the lizard birds? Mr. Evolutionist, can you please share with me one example of a lizard having feathers, please, that's alive today? Oh, you can't give me any. Oh, interesting. You know, that makes sense, because don't feathers insulate a cold-blooded creature? That kind of is completely opposite of what a cold-blooded creature should have. You put lizards under a heat lamp for a reason, because they don't generate their own heat. So insulating would be what? Worse. So you can use this stuff. You don't have to say, Bible God, just throw a wrench at them. Let them struggle for a while. And then when they struggle and they self-implode, then you share the gospel with them. Okay? Because you can't give them a foundation, Scripture, God, if they already have a foundation. Evolution, science. You have to destroy that before you can give them something new. Okay? The child, right? You can't give them a new toy unless they get rid of their old one, or they stop playing with their old one. Same reasoning. Okay? So you can pick which one. I'm just trying to give you a couple of different things that you can really mess with them with. Okay. Now, finally get... Nope, we have one more slide. Crud. I forgot how many slides I have in this. Sorry. Okay, so going back to intermediate forms. Okay. Are there any dogs and cats with different chromosome numbers? Are there any in-betweens for cats and dogs? Mr. Evolutionist, where are all the intermediates between cats and dogs? Oh, they're extinct. Oh, interesting. If they had to have all these miraculous chromosome changes, then why aren't there any dogs with different chromosome counts? Oh, they all went extinct. If they all went extinct, then were they worse or better than their previous selves? Worse. Oops. Right? Mess with them. Okay? Chromosome changes need to occur for evolution. So, Mr. Evolutionist, where are these chromosome changes? Please show me. There's only one chromosome change that I'm aware of. Down syndrome. Okay, does anyone know the problem with Down syndrome? What causes Down syndrome?
Isn't it? I thought it was lesser and extra.
They have an extra copy of chromosome 21. Okay? Now, extra copy. Does that mean they have any new information? No. It's just a duplicate. It's just your DNA making an extra copy of one chromosome. It doesn't add anything. It doesn't take away anything. People with Down syndrome, normal. Okay, people with Down syndrome. So if I took a dog and then I gave the dog Down syndrome, would the dog with Down syndrome survive better than a normal dog out in the wild? No. Okay, and this is a tough topic, right? But the reason I say this is because they have an extra chromosome, a one chromosome change. That's the only example I can think of. Of course, there's amphibians who are all super weird with a bunch of exceptions, right? Problem is, we didn't evolve from amphibians according to evolutionary history. We evolved from monkeys. So it doesn't matter if amphibians are weird. What matters is monkeys aren't weird. Okay? One extra copy causes problems. You're not normal. You're not as functional as you could be. Okay? It's terrible. It's a fact of a world in sin, right? It is. It's awful. But for the scientific case, one extra chromosome that doesn't add anything new causes you to be what? Beneficial or harmful? What's this change? Harmful to the individual, not beneficial. What's that?
There's two ways to look at it, though.
Yeah.
You know, I'd say it'd be beneficial because they're always going to have that childlike faith.
They do.
That's true. That's beneficial.
They absolutely do.
You ain't got to worry about going to hell because they're promised already.
Mhm.
The kingdom.
They are some of the most loving people you will ever meet.
Oh, yeah.
Okay, they are. I know this sounds cruel of me to say, but I'm trying to take a cold scientific approach to it. But trust me, I have someone in my life who has complications. I love him to death. Happiest person I know. Okay, but hands down by far, no questions asked. Okay, so yes, you're right that there is give and take. There is harm and benefit. But when we're talking about nature, cruel, uncaring nature, they don't care about how nice the dog is. If the dog doesn't run away from the lion, the dog is dead.
And isn't there also reproduction problems?
Yes, people with Down syndrome have reproductive problems. They have extra chromosomes and that messes everything up.
So can they reproduce?
They can, but it's excruciatingly rare. And if they have kids and their kids have Down syndrome, then they probably don't reproduce. That's even rarer to have a Down syndrome reproduction. Usually what happens is if they reproduce, it corrects itself, if they are to be fertile. So yes, there are exceptions, but like I said in the very beginning, the further you go down the line, it'll correct itself or it will become infertile. There's only two options, correcting or infertile. There is no alternative, okay? Scientifically speaking. Evolution says one thing, but scientifically, you can't argue with it.
Like most hybrids, their temperament is more calm. So
Really?
A tiger is more calm than a tiger and a lion.
I did not know that.
That must be a hybrid then, 'cause I'm really calm.
Being calm in nature is not always a good thing either. It's probably a bad thing, right? Because what's the saying? It doesn't matter the size of the dog in the fight, but the size of fighting the dog. So if you have a nice, lovable 900-pound liger, all you get is one big meal, right? That's interesting. But yeah, the more you look into this stuff, the more you are passionate about it, or if you want to talk about something else, just use the same reasoning. Interesting. Their testosterone gets tanked because of the hybridness?
So when you have hybrids, the male has less testosterone than both species. So females, when they do have a baby, the females are the ones that have the baby that is able to reproduce. But like you said, it like kind of comes to a point of where it dies. But males are usually infertile. So that's why if you have people who are born with not just Down syndrome but other like genetic mutations, they have to go through like IVF and take testosterone to produce more testosterone. So their sperm count's lower, so they can't have babies.
That is interesting.
So that so guys should go get testosterone shots so they never lose it.
Guys never. I mean, if you're a man, you can have a baby.
I'm not talking about the baby part. I'm just talking about testosterone.
And activity level and diet and all that stuff.
Yeah. It's so cool. Science is so cool. I mean, you could watch documentaries all day. I just wish they wouldn't put the evolution crap in there and just stick with the facts. That's what I would wish. If PBS wasn't preaching to you about evolution and instead just talking about how cool nature was, right? Okay, so getting back to well, we can just skip this for now. Okay, next, this is the last slide. Okay, now, as a summary, how do the different counts come into being? Mr. Evolutionist, how do the different counts come into being? When you have a different count, you are infertile, your children are infertile, or your testosterone's lower, or whatever the case may be. How is it possible you get all the different counts? Well, if they did, all we know from changing chromosomes is it's either harmful because they're infertile or harmful because it has some kind of disorder, or it'd be miraculous for it happening in the first place. So it'd be miraculous and harmful that this thing actually did happen. So What would survival of the fittest have to say, Mr. Evolutionist? Harmful, weaker, extinct. How can something pass on a change if it's extinct? It can't. You can't pass on your genetics, your genes, if you're dead. That's cold hard facts. There is little current proof, that animals with different, that I can't grammar today. Okay, I'm not even going to try to read that. Basically, there is little to no proof that animals can have different counts, okay, and have regular normalness without these weird genetic disformities, right? It just doesn't happen. Science does not have that happening, okay? So, that's the skinny of it. Any questions about anything I said? If not, we can talk about ligers more.
Do we have any proof of anything having like Down syndrome, of any species having
All animals can have Down syndrome.
another?
Yeah, all animals
They
can,
all
yeah.
have the similar, like the eyes and even like,
wow.
yeah.
But I mean, do we have any proof of something getting another chromosome and surviving? Like,
Oh, they survive. It's just
well, I mean, like, okay, the mule thing. I get the mule thing, but I mean, like, to come up with. Has there ever been a recorded instance where anything has ever gotten, two things have gotten together where it's actually worked, that they could reproduce? Is there? Did you ever look at that? Is there any?
evolution. You can look on sites, and they will be very quick to say, "Oh, yes, there are exceptions," and talk about a liger having a child, right? Being fertile, the liger's fertile, but with males and females, eventually, they'll point out the exceptions. But they won't tell you that eventually it either corrects itself or they become infertile.
So like the female liger can reproduce with the male liger if by chance it can produce sperm. But if a female liger goes with the tiger, it's like genes, then the genes, it becomes a tiger again. So if a female liger and a male liger happen to have a child, a baby liger, that baby liger usually doesn't make it past its like cub stage. So they can, a lot of these can reproduce, but about, what is it, the second generation? So the first, I don't know what generations, but so like the liger and then the other liger or the hybrid and the other hybrid will have a baby, but that baby hybrid usually doesn't make it past childhood.
Do they just do this in the wild? Like a lion
Sometimes
and a
it's
tiger?
Sometimes it's like a so you know how they have, what is it, the deer, like when deer go crazy and do weird stuff. Kind of like rabies, you know, rabies makes animals do weird things. Like sometimes there's that like going on in the population where just like a liger. Sometimes it's like people will release an animal, like they have a big thing in Florida with like boa constrictors out competing the like snakes that are naturally there. So like boas, and then so sometimes, but usually there's a human like factor in all of it.
Yeah.
Like somebody, Saudi Arabia brought a tiger and a lion and let them both go, and then